In this video, we'll be looking at Chapter 10, Section H on problem solving with the sine and cosine rules. Now, let's quickly review what the sine and cosine rules are. Now, we've seen these rules before, and we're not really going to learn any new information here. We're just going to use these rules to help us solve some word problems. But it's important to note that you should always use the cosine rule when given a choice over the sine rule, because the cosine rule gives us one answer when we're finding an angle, whereas the sine rule gives us two answers when we're finding an angle. So again, always use the cosine rule when given a choice. Let's take a look at an example problem. An aircraft flies 74 kilometers on a bearing of 38 degrees. It then changes directions and flies 63 kilometers on a bearing of 160 degrees. And we're asked to find the distance of the aircraft from its starting point. As always, we should start with a picture. And we'll start with point A. And remember, since we're dealing with bearings, we always want to draw the north line, because our first bearing is 38 degrees, which is roughly in this direction, until we get to point B. And then the aircraft changes directions and flies on a bearing of 160 degrees, till it gets to point C. Now we know this angle is 38 degrees, and we know this angle is 160. We know the distance from A to B is 74 kilometers, and we know the distance from B to C is 63 kilometers. Now we're asked to find the distance of the aircraft from its starting point. So we want to find the distance of line AC. And you can see that I've drawn a triangle here, and if I knew enough information, I could use either the sine rule or the cosine rule to solve this problem. Well, remember, we always want to use the cosine rule if at all possible, because it leaves us with an unambiguous answer. And to use the cosine rule, I need two sides and the included angle. So let's see if I can figure out what this angle B, is in the triangle. Well, I know the bearing from B to C is 160, and I know I can figure out the angle below the east line, which is 70 degrees. I can also figure out this angle here, because I know that if I were to drop a line straight down, this line is parallel to the north line at A, and therefore these two angles have to be complementary. In other words, these two angles need to add up to 180. So 180 minus 38 gets me an angle of 142. Now, I actually don't even need this value here, this value of 70 degrees, because notice what I've done is I've split this 360 degrees into three sections, a 160, a 142, and what's left over here in the triangle. So really all I need to do is subtract 142 and 160 from 360 degrees. And that gets me an angle of 58. So this is the angle inside the triangle at point B. Well, now I know two sides and the included angle in a triangle, which means I can find the third side. which in this case is side B. So I'm going to use the cosine rule here. B squared equals A squared plus C squared minus 2AC cosine of angle B. Well, if I plug in the numbers, I have 63 squared plus 74 squared minus 2 times 63 times 74 times the cosine of 58 degrees. And remember, I need to take the square root of all of this because I'm trying to find b, not b squared. So if I take the square root of all of this, I find that b is approximately 67.1 kilometers. This example problem is a little bit trickier, partly because of the wording, so we really need to be careful when we're reading the problem to make sure that we're setting up the picture correctly. So let's read through it once and then we can draw the correct picture. We have Mount X, which is 9 kilometers from Mount Y on a bearing of 146. Mount Z is 14 kilometers away from Mount X on a bearing of 72 degrees from Mount Y. And we'll be careful with this part because it's a little tricky. And then we're asked to find the bearing of X from Z. So let's start with Mount X and Mount Y. We know that Mount X is 9 kilometers from Mount Y on a bearing of 146. So we start with the north line, and in this case I need the east line as well. I'm going to draw a bearing of 146. I'm going to draw a line down to X. And we know that this line is 9 kilometers. Now this is where the tricky part of the problem is. Mount Z is 14 kilometers away from Mount X, but it's on a bearing of 72 degrees from Mount Y. So I need to draw another line from Mount Y, which is a bearing of 72 degrees. And this brings me to point X. Point Z. We know that that bearing is 72 degrees. We also know that Mount X is 14 kilometers away from Mount Z. And again, we're asked to find the bearing of X from Z, so I need to start at Z and find the bearing to X. And it looks like it'd be about 180, but I have not drawn this picture to scale, so we need to be really careful with making assumptions like that. Let's fill in as much information as we can about the triangle and then use either the sine rule or the cosine rule to find that bearing. Let's take a look at the angles at Y. We know that this angle right here is 146 minus 90, which is 56 degrees. We also know that this angle right here is 90 minus 72, which is 18 degrees. So I know the angle inside the triangle at point Y is 56 plus 18, which equals 74 degrees. So let's redraw our triangle here. We have Y, X, and Z. I know that this is 74 degrees. I know the length of this side is 9 and the length of this side is 14. Well, notice I have a side opposite an angle and another side, which means using the sine rule I can find this angle here. So let's set up the sine rule to solve for that angle. We'll call it the sine of z over 9 equals the sine of 74 over 14. So the sine of z equals 9 over 14 times the sine of 74. And if I take the inverse sine here, I can solve for z. And I get that z is approximately 38.2 degrees. But remember, because I took the inverse sine, it could also be 141.8. But if we take a look at 141.8 and the angle that we know, 74, I add those two together, that's impossible because those two angles alone are greater than 180 degrees. So this is a case where I can get rid of the second answer, and I know that the angle inside the triangle at z is 38.2. Now again, just in like we had in the previous problem, I can find this angle from the parallel line theorem. I know that this angle has to be the complement of 72, so it's really 108 minus 72, or, I'm sorry, 180 minus 72, which is 108 degrees. So now I have three parts of 360 degrees, or I know two of them. I can find the third by subtracting these two angles from 360 degrees, and that's going to get me my answer. So if I do this quick calculation, I get 213.8 degrees, and that's my bearing of x from z. And we can see that my drawing was not drawn to scale. This angle is slightly past 180 degrees, so there should be a little bit more of an angle to my line between x and z, but the math wins out in the end and gives us the right answer.